Welcome to edupediaworld.com. You're watching the videos on statistics, right? So in this video, we'll discuss again some more questions related to presentation of data, right? So we'll discuss some of the more important questions which are very important from the exam point of view, right? So you have to watch this part of video very carefully again. So let's discuss the question one, which is question number one now. The question says that the heights of 50 students measured to the nearest centimeters have found to be as. So these are the following heights of 50 students, like measure nearest to centimeters, right? So again, we need to represent the data above by a group frequency table, taking the class intervals at 160 to 165, means the class range should be 5. And second part is what can you conclude about the heights from the table, right? So let's see how we can solve this question right now, right? So this means we need to draw a distribution table, right? So let's draw it first like this, right? Now we can have three columns. Why? Because the data is large, so we can have telemarks. So for our convenience, right? So let's say we have three boxes like this, right? And let's say overdraw over here like this. So we can say heights in centimeter over here, right? And we can write telemarks over here, and we can write frequency over here, right? Now, so the class range should be 160 to 165. This means, so we need to search first for the lowest value. So we can see properly the lowest value is 150, right? And the highest value we can need to search, right? So 172 we can see and we can compare, right? So we have 173, right? So we can write over here the minimum value is 150 and the maximum value is 173, right? Now, so let's do it now. So first class will be 150 to 155. Second will be 155 to 160. Then 160 to 165. Then we have 165 to 170. Then we have 170 to 175, right? Now in between 150 to 155, you need to remember the value should be less than 155. So we need to count how many. So we can take this as 1, 2, 3, 4, 5, right? Then we can take this as 6, then 7, right? Then we have 8, 9, 10, right? Then we have 11 and we have 12, right? So we need to draw the telemarks 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and the frequency is 12, right? Now between 155 to 160, we need to count. So this means value should be less than 160, right? So over here, we need to be very careful. So this can be the value 1, 2, 3, right? 4, 5, right? Then 6, 7, 8, and 9. So we have 9 values. So this is 1, 2, 3, 4, 5, 1, 2, 3, 4. So we have 9 values over here, right? So then next is 162, 165. So this means the value should be less than 165. So this will be 1, 2, 3, 4, 5, then can have this 6, right? Then 7, 8, right? So it should be less than 165. So till now we have 8. We can have 9, 10, 11, right? 12, 13, and 14, right? So we have 14 values. So we need to draw 14 tally marks. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. So this is the 14 values now. So 165 to 170. So it should be 165, but should be less than 170, right? So this is 1, 2. Then we have 3. Then we have, can say 4, 5, 6, 7, right? 8, 9, and 10. So we have 10 values, right? So between 165 to 170, we have 10 values. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it is 10 values. Now 170 to 175, we need to count. This is 1 and this is 2. So we have 2, then 3, 4, any more, and this is 5. So we have 5 values. So 1, 2, 3, 4, 5. So we need to write 5 over here. So now we need to add this frequency to check with the number of students, right? So 12 plus 9 is 21. 21 plus 14 is 35. 35 plus 10 is 45. 45 plus 5 is 50. So we have 50 students. So this is matching. So which is total is 50, right? Now, so next we need to write what can you conclude about the heights from the table. So we need to tell what is the conclusion we can draw. So if you can see properly, we have 50 students, right? So if you add these three, let's say 12, 9, and 14, so it will be 21 and 14, which is 35. So till over here, we have 35 students covered. You can see properly, and remaining 15 students come under this height range, right? So we can conclude that, so we can say that one conclusion that we can draw from the above table is that more than 50% of students are shorter than 165 centimeter. Means on an average the height of a student is less than 165. So this is how we can conclude the data, and we can present the data, and from that we can infer the information we need to get, right? So let's move on to the next question, which is question number 2. Now the question says that a study was conducted to find out the concentration of sulfur dioxide in the air parts per million, which is also known as ppm, of a certain city. The data obtained for 30 days is as follows. We need to make a group frequency table for this data with class intervals as 0 to 0.00 to 0.04, like this. So we need to have 4 as a class size, right? And we need to write for how many days was the concentration of sulfur dioxide more than 0.11 parts per million, right? So we need to write. So let's see how we can do this question now. So some very similar question. Let's do it quickly then. So first of all, we need to draw the frequency distribution table, right? Like this. like this. We have a frequency distribution table. So we need to write concentration of sulfur dioxide in ppm, right? So we need to write over here as frequency, right? Now the class interval should be 0.00 to 0.04. So we need to write 0.00 to 0.04, then 0.04 to 0.08, then 0.08 to 0.12, then 0.12 to 0.16, 0.16 to 0.20, then 0.20 to 0.24, right? Then we need to count, or we need to count how many the values come between the classes, right? So again we can follow the same process. So value should be, first for the first class the value should be less than 0.04. So this can be 1, then we have 2, right? Then we can have 3, right? And this is 4. So we have 4 as a frequency for the first class, right? Now next is 0.04 to 0.08. So it should be less than 0.08, right? So this can be the 1, 2, 3, 4, 5, 6, 7, right? 8 and 9. So we have 9 as a frequency. Then 0.08 to 0.12 should be less than 0.12, right? So we can say 1, 2, 3, then we have 4, then we have 5, 6, right? Then we have 7, 8. Any other value you can check, right? So we can count again. It can be 1, 2, 3, right? Then we have 4, 5, right? Then we can have 6, 7, 8, right? Then we can have 9. So we have 9 as the frequency. Then from 0.12 to 0.16 we need to count. So this means this cannot be included, right? Then we need to search. So we have 1, right? We have 2, any other value, right? So there is no other value, so we have frequency as 2. Then we have 0.16 to 0.20. This means we can include 0.16, but it should be less than 0.2. So this can be 1, 2, right? 3, right? Then we have 4. So we have 4 values. Then 0.20 to 0.24, right? So this is 1, right? Then we need to search. Let's do it. So it should be equals to or greater than 0.2, but should be less than 0.24, right? So this means we have 1, then we have 2. So we have 2 values. So 2 will come over here, right? So we need to add to check whether we are doing the correct distribution. So it will be 4 plus 9 is 13, 13 plus 9 is 22, 22 plus 2 is 24, 24 plus 4 is 28, 28 plus 2 is 30, right? So we have 30 values. You can say that the total is 30, right? Now So second part says that for how many days was the concentration of sulfur dioxide more than 0.11 parts per million? Means it should be more than 0.11, right? So over here, till this range, we can include 0.11. So it should be more than this. So this means we need to exclude the data till over here. We need to exclude the data till over here. Why? Because upper value we cannot take. So this means till this class only 0.11 type of values or less than 0.11 can be accumulated. So this means we need to find the concentration of sulfur dioxide more than 0.11 parts per million. So this will be the range of data. So we need to add all these frequencies, right? So it will be 2 plus 4 plus 2. So it will be 8. So this means we can write over here the concentration of sulfur dioxide was more than 0.11 parts per million for 8 days, right? So it was for the 8 days. So this is how we can extract the information from the presentable data, right? So let's do the next question, which is question number 3. Now, the question says that the 3 coins were tossed 30 times simultaneously, right? And each time the number of heads occurring was noted down as follows. So this means these are the number of heads, and the coin was tossed 3 times simultaneously, right? So we need to prepare a distribution table for the given data. It's a very nice question when you will do the question like this in a probability. So it will be very helpful for you. So please watch this question very carefully, right? So let's do this question quickly also. So this means we need to draw table like this, right? So let's say we have a table like this. So we can say number of heads and frequency, right? Now 0 we need to count. We have 0, 1, 2, 3. So we need to write 0, 1, 2 and 3. We need to count how many zeros. So this is 1, 2, 3, 4, 5 and 6. So we have 6 frequency. For the 1 we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 over here. For 2 we have 1, 2, 3, right? 4, 5, 6, 7, 8, 9. So we have 9 over here. And for the 3 we need to search. This is 1, 2, 3, 4, 5. So we have 5 over here, right? So we need to add. So this will be 10 plus 6, which is 16. 16 plus 9, which is 25. And 25 plus 5, which is 30, right? So we have 30 as frequency, right? So this is the total, right? So this is how we can use the data, and we can use any other type of data to represent in the presentation form. So thank you once again for watching this video on edupediaworld.com. Keep watching further videos. Have a nice day.